The focus of this video lesson is driving safety. Now, a conservative rule of thumb for reaction distance is that a car travels about 1 foot for each mile per hour of speed. So consider that when driving too close to another vehicle. If they stop, it's going to take you about 1 foot for every mile per hour you're driving in order to stop. Let's take a look at what this means. Example 1. What is the reaction distance for a car traveling approximately 48 miles per hour? All right, so we're going to try to solve this problem 2 different ways. The first way is we're going to use the rule of thumb. Now remember what the rule of thumb said. It said that the reaction distance is going to be about 1 foot per mile per hour, right? So we know we are going 48 miles per hour, and according to the rule of thumb, we will move 1 foot per mile per hour. In other words, 48 feet. Now, we're also going to solve this using a little bit of research and calculations. Now, according to research, researchers have determined that the average driver takes between 0.75 seconds and 1.5 seconds to recognize a hazard in the road. So, reaction. So you're driving along and you see something, and it takes about 3/4 of a second to a second and a half for your brain to tell your foot, hit the brake, right? And during that time, your car is still traveling. So using that and using what we know about distance over time, let's go ahead and calculate a range. Okay, so we know that this car is going 48 miles per hour. And we know that there are 5,280 feet in a mile. Therefore, we know that this car is traveling 253,440 feet in an hour. Now, because our research is in seconds, let's do a little bit of dimensional analysis and let's convert our measurement from feet per hour to feet per second. So we have 253,440 feet per hour. We know that there is in 1 hour 60 minutes. And in 1 minute, 60 seconds. All right, so that is 253,440 divided by 60 2 times. So we'll take our calculator, 253,440 divided by 60 minutes divided by 60 seconds, and we get 70.4 feet per second. Okay, now what does that tell us? Well, if it took us 0.75 seconds to react, right? So we have 0.75 seconds per, right? And we're going 70.4 feet per second. How far will we go? So 70.4 times 0.75, and that's 52.8 feet. Now, if instead we were doing 1.5 seconds to react, then that would be 1.5 seconds times our 70.4 feet per second, which is 1.5 times 70.4, or 105.6. All right, so we're going to say then that the reaction distance is between 52.8 feet. I'll write that a little bit neater. 52.8 and 105.6 feet, which is a pretty large difference. Okay, now do note that the rule of thumb is a good kind of estimate of it will take you at least this long. Using the research will give you kind of a better range. We don't all react the same sort of way. Research shows that people react between this 3/4 of a second and 1.5 seconds in general. But obviously this should make it clear to you that the faster you are moving, the longer you will travel once reacting. Now it's your turn to try. Try this. A car is traveling at 65 miles per hour. Approximately how far will it travel during the average reaction time? Give me both the rule of thumb and give me a range. All right, example 2. What is the approximate braking distance for a car traveling at 48 miles per hour? Now note, in order to stop your car, 2 things have to happen. First, you have to react. In other words, recognize that there's something in the road that requires you to brake, and then you have to actually brake. So we need to determine how long it will take your car to brake and fully stop. Okay, the general formula for braking distance is s² over 20, where s represents the speed of the car. So the approximate braking distance for a car traveling 48 miles per hour, we're going to say that s here is 48 miles per hour. And we know that our braking distance is given by that formula, s² over 20. So we have here 48² over 20. Using our calculator, 48 squared over 20. So it's about 115.2. So based off of this formula, it will take us 115.2 feet in braking distance. Try this. What is the approximate braking distance of a car traveling 65 miles per hour? And what factors also need to be taken into account that might add or subtract from this braking distance? Example 3. Rachel is driving 48 miles per hour on a 1-lane highway. She sees an accident directly ahead of her, about 200 feet away. Will she be able to stop in time? Okay, now remember, our total stopping distance is a combination of our reaction distance and our braking distance. For this specific one, let's just use our rule of thumb for our reaction distance. So if you remember from example 1, traveling 48 miles per hour, the reaction distance will at least be 1 foot per mile per hour. So we're going to say our reaction distance is at least 48 feet. Our braking distance, remember, is calculated using our formula 48² over 20. Now, if we remember from example 2, 48² over 20 was about 115.2. So we have here 48 feet plus 115.2 feet. So 48 plus 115.2 is 163.2 feet. And that's our stopping distance, approximately. Now, if your reaction time is longer, that could change everything. So the question is, will she be able to stop if she's 200 feet away? Yes, 163.2 is less than 200. She will be able to stop. Try this. What is the total stopping distance for a car traveling at 65 miles per hour? Use try this 1 and 2 to help you get this. Will she be able to stop if she's 200 feet away?